Do we have free will? That's a question you often hear debated. As you listen to the debate, you may sense that the real issue is, what sort of world do we live in? Let me put my beliefs on the table and tell you what I think about the real world. Any explanation of reality must explain how we got from this moment in time to the next moment. We need a grasp on the unstoppable progression from now into the future. Only with that understanding can we answer questions such as, how do we fit into the world? Or do we exert any agency in this world? For much of history, people have taken a dualistic view of the world. The dualistic view talks about two domains, an eternal domain and a mortal domain. Everyone grants that physical processes are at work in the mortal domain, but dualists see other processes or agents from an eternal domain that influence the course of events in the mortal domain. My viewpoint is non-dualistic. I believe there is just one world, and that world has processes operating that produce the transition from this moment in time to the next. To answer the question about free will, it is worthwhile to consider three processes. The big three that appear in this discussion are physics, natural selection, and identity. You only need to know a little bit about each, and I'll try to point out the ideas along the way. Today, I want to talk to you about the question of whether we can attribute free will to ourselves and others, or whether any talk of free will is just an obsolete remnant of ignorant times. Some kind of superstitious faith in our own autonomy. Let's start with a word about faith.
Many religions teach that all of us in this discussion have a soul which is embodied during life in physical matter. However, religions teach that our soul is something other than matter, and our soul can exist without a body. The soul could have free will, even if the body does not. Some might vigorously debate the nature of the soul, but let's not go there. Let's stick to natural philosophy as humans can know it. Most discussions I've listened to rely on physics to give an answer. If physics is the starting point, the answer always seems to be no, there is no free will. It is easy to explain the reasoning. Given a set of initial conditions, the equations of physics predict the future. You can verify this with experiments. The equations work. So, if we are physical beings in this world governed by physical laws, then what happens is already knowable from initial conditions. No matter how complicated and frankly ridiculous the connection between cause and effect may be, the cause determines the effect. There is no room for free will. I don't like that answer, in spite of the fact I have nearly complete faith in physics. So I need to justify my faith in physics with my understanding of free will. I'll try to explain during two passes over the scene. Let's consider what physicists believe. In this first pass, I'll tell you why you should believe in physics. First of all, physicists get accurate, reproducible answers by making measurements and putting them in mathematical equations. The language of physics is mathematics. However, any language can also deceive. You can write a mathematical description of a universe that doesn't exist. For example, when I was in graduate school, there was the mathematics of the so-called eightfold way, which explained what was known about elementary physical particles then. The eightfold way involved marvelous mathematics, but failed to describe experiments that unfolded in subsequent years. Now the idea is just a historical footnote. Any combination of ideas in mathematics must always be put to experimental tests. When it passes, we know the mathematics is true of the physical world. After it is tested, physics really works. Okay, say you can believe in physics, but can you trust it on the question of free will? Physics says that the present moment exactly determines the next moment in time. Where is room for deviations caused by free will? If there is no free will, no deviation from the fixed trajectory of the equations of science can exist. Gee, then isn't life pointless? So, which way forward? I've struggled to figure out how to start this talk. For better or worse, my starting point is just this idea. Life is pointless. That might be my reaction if I thought none of us have free will. Why make an effort if the world is running on fixed railroad tracks? The thought gets more interesting when the writer of the words is more creative. Probably you've heard this idea expressed the way Shakespeare phrased it in Macbeth's speech near the end of the eponymous play. Tomorrow, tomorrow, and tomorrow creeps in this petty pace from day to day, to the last syllable of recorded time, and all our yesterdays have lighted fools the way to dusty death. Out, out, brief candle! Life's but a walking shadow, a poor player that struts and frets his hour upon the stage, and then is heard no more. It is a tale told by an idiot, full of sound and fury, signifying nothing. Shakespeare's words are creatively placed in sequence in a sentence, so Macbeth can lament the collapse of his life's ambitions and dreams. It is moving for people to listen to the speech, but listening to Shakespeare is a process beyond physics, beyond mathematics. You can't experimentally verify speaking or listening or interpreting. Nothing is falsifiable. No mathematics enmeshes the meaning in provable theorems. Also, don't forget, we know that the events of Macbeth's tragedy never happened. The events live on paper and in our collective imagination. The story is both real and not real. How can that be? What is this reality that exists in the physical world and depends on the physical world but is not described by physics? I'm going to show you patterns and then claim that patterns are real. Here's one way to look for a pattern. If you're old enough, you may remember being a student and being forced to diagram a sentence in chalk on a blackboard in front of your bored classmates. Here is the diagram for the first of the sentences in the quote from Macbeth. You will find all the words of Shakespeare's sentence in this diagram, but the words are connected here by lines that show a relationship between words. The lines form a pattern that relate words according to the syntax of the English language. Without understanding the language, and without an ability to parse out the relationships of words, nothing we read or hear would be intelligible. So Shakespeare did more than put physical ink on physical paper. He also structured words and tokens according to a grammar, and the results had meaning for us. Here are some of the ways that Shakespeare's words evoke meaning and thoughts in my own mind. First of all, when I see creeps in this petty pace, reminds me I've been frustrated. Things often move far too slowly for my ambitions or my goals. To the last syllable of recorded time. Whoa, somebody is watching, keeping track of everything we're doing. Life's but a walking shadow. A poor player. Ah, that's me. I could have done better. And at the end, signify nothing. Life is pointless. QED. An author shapes words in a pattern that generates connections between the author and the audience. When Macbeth speaks his lines on the stage, connections are drawn between my mind and that of Shakespeare across century. What I'm driving at here is that there are things, connections between things, and patterns in those connections. These make up our natural world as living beings. Everything exists in the physical world, so you need to understand where there's room in this natural world of patterns and connections within the framework of physics which underpins the natural world. Finally, let me point out that patterns of words authored by Shakespeare have been reproduced and exist in countless copies on paper, film, digital media, and even this PowerPoint presentation. Now let's look at another quotation. Hell hath no limits, nor is circumscribed in oneself place, for where we are is hell, and where hell is must we ever be. Wow, that quotation is pretty dramatic. In its day, those words were widely declaimed on stage by actors to an attentive audience. The word's author, Christopher Marlowe, was a playwright contemporary with Shakespeare, and arguably just as successful or more so in his time. But in our time, his words are rarely heard. I found the words by asking the internet what Marlowe said that is famous. The internet oracle assures me these words are some of Marlowe's most widely known. I ask myself, though, why have I heard Shakespeare many times and I'm reading Marlowe's words for the first time? Why have the words of Shakespeare and Marlowe, published as much in their own time, suffered such different fates? Shakespeare's words are abundant, and Marlowe's only niche dwellers. Perhaps you can guess where I'm heading. To natural selection. Words, sentences, paragraphs, and whole text are impressed on physical media. The words get copied and recited. Words embodied in media proliferate, but also media gets thrown in the trash, erased, or forgotten. Only those patterns or words that reproduce quickly can survive from the 16th century to the 21st. Much is created, most of it is lost. Many forms and patterns arise, but only some multiply in the Red Queen's game of natural selection. Let me paraphrase and adapt the last sentence of Charles Darwin's On the Origin of Species. There is grandeur in this view of life, whilst this planet has gone on cycling according to the fixed law of gravity. From so simple a beginning, endless forms, most beautiful and most wonderful, have evolved. It is these forms, most beautiful and wonderful, that we must surely understand to understand free will. I mentioned earlier, I believe, that 3 areas of study are necessary if we want to understand how the future is determined and whether there is something called free will. So let me point out that we've now mentioned 2 of the 3 areas of study, physics and natural selection. Now it is time to approach the least examined of these areas, identity. Now when I say identity, I'm not talking about your pronouns or ethnicity. I'm only interested in what there is that exists in the real world and attracts labels and names. If you read your Bible, it says in Genesis, "And out of the ground the Lord God formed every beast of the field and every fowl of the air, and brought them unto Adam to see what he would call them. And whatsoever Adam called every living creature, that was the name thereof." Just like that, whoever makes something gets to name it, or they can delegate naming to a lower being like somebody named Adam off the street. So that was a digression into ancient mythology. But let's play with the idea of names in a modern context. To keep it as light as possible, let's start with a picture, just an ordinary picture from an iPhone that I will use with names and words to modify the picture. Here is the starting point. I was out for a walk last fall and saw a display of tree leaves that struck my fancy. Like anyone else would, I whipped out my phone and captured an image. Then I got home and was very disappointed. The digital image just doesn't show what I thought I was looking at. I realized quickly that the background in the digital image distracts from the pattern. So let me jump to something like what my mind saw at the time. This is the previous pattern, but showing only the leaves. Now, without the fence and the wires in the background, you can see the pattern. I'd love to use this pattern as a decoration on a wall. So what separates the 2 patterns? You might guess Photoshop, and you would be right if I knew how to use Photoshop, but I don't. However, as an ex-programmer, it was easy enough for me to sit at my computer and type a few lines. Here is part of the text I typed. The text on the screen is written in a computer language called Python, but you don't need to know any Python language for what I'm going to point out. The first thing I need to say is that if the text is red, that is a comment for me and you. The computer ignores all the comments in red. The first line introduces 2 names. The first name is the acronym PIL, which stands for Python Image Library. The second name is image, a word that sounds like one we use in English. The resemblance is intentional, of course. The first word on the line is the word from, which tells a computer to take something from PIL from somewhere. Somewhere is up for the computer to find out. The computer is very good at that. Now I've indicated I want something named image from something named PIL. If the Python image library doesn't have the thing called image, the computer will stop here and complain. But it finds it. At the end of this first line, there is something in my computer named image that flew in off the internet. Now I can use the name image. However, first I need to let the machine know about the photo of fall leaves from my phone. I know where I put the photo on my computer, but the place name is long, so I give the place name a short name, which I call iFileName. You see, this is really very easy. You know the names of things already there, or you name the ones that you make when you make them. That's half the battle. It's all over. Here is another example of language text. I made up a name that I spelled IMGT for a temporary image, just kind of a crazy acronym, and gave this name to a new temporary object in my computer that is created when the computer sees the verb open. Open is a very common verb used as a command to a computer to tell it to bring something into the realm of discussion. Open is an action. We may not always think about this aspect of language, but text and speech are about action, even if the action has no visible physical effect. For example, if a politician says his opponent is a goose, he wants the words to act on your mind to connect his opponent's reputation with the image of a goose. Computers work the same way. Speech causes action. The PIL library that the computer visits when it reads my text must be vast, like several large reference books densely packed with writing. There is a section in the vast PIL text that is conveniently labeled or named image. The image piece may only be the size of, say, a magazine. I have no interest in how large or difficult these documents may be. Once they're written and named, I just refer to them and use them by name. That's why naming identity is so powerful. Writing and naming are big activities for software practitioners, and if you philosophers think about it, that's what you do too. Here is one last example of software writing. Here I'm using a named function called getPixel to do pretty much what it says. Get a pixel out of an image so I can alter it. The name is defined by text in the block named image in the much larger library named PIL. So what makes a good name? Well, the name should suggest the function of what it names, like the function getPixel. The controversial aspect comes when you must draw boundaries around text and assign a name. For example, how do you lay out a book so each chapter gets an effective chapter title? Here is one of the rules we teach. Suppose we represent text elements with colored circles and relationships between those text elements by arrows. We might get a diagram like this. Now, let's assign names to groups and use a color to show what element goes with each group. This diagram illustrates a desirable kind of assignment. Within a chapter of a well-written book, or within a well-structured software text block, text elements make many references to other text in the self-same chapter or block. That quality of local reference is called cohesion. On the other hand, there should be only a few references outside the chapter or text block. Relationship lines going outside are called coupling, and coupling is regarded as bad because the reader must jump all over the place to understand what is going on. So we assign names and colors in a way that cohesion is large and coupling is small. Do this and your writing will improve, whether it is in software like Python or in English. Now think about your mind. Have you ever reflected on how your mind is a web of memories, current plans, in dreams for the future? Internally, you are a vast web of connections. Your coupling with others is actually relatively minimal. Your boundaries are physical and visible. It is entirely logical that you, as an individual, have a name. There is just one you, and it is unique, cohesive, and only loosely coupled to others. What names achieve for us is the possibility to name patterns that proliferate in the world under the supervision of natural selection. The labels let us see new relationships between those named things, those collections, those objects, those patterns. With these new relationships, we can then learn to predict the future and even influence that future. Getting back to people like yourself, give yourself some credit. You have a brain. The brain runs active processes to observe the world and its many changing patterns. You learn, and thereby you update your memory with facts about what patterns and relationships exist out in the world. And based on memory and reasoning, you can generally predict what is coming next. As an infant soon realizes, you discovered long ago that what you do, starting with smiling or crying, is going to change the world you are observing. Thus, you act to give yourself the future you desire. You change things. You can easily guess my viewpoint on free will. I want to argue that the future is determined by choices made by independent agents, like you and me. That conclusion is different from what we might infer from the deterministic laws of physics. So let's continue to explore that disconnection. I've introduced 3 branches of natural philosophy that I believe are essential for understanding free will. Now it is time to say a little bit more about each. I'll start with physics, returning to the claim that physical determinism precludes any element of free will. Here are the points about physics that I made earlier, plus another one. From the sound of it, it makes free will sound very unlikely. It is called the totalitarian principle. Murray Gell-Mann was a Nobel Prize-winning physicist known primarily for his advances in understanding elementary particles of nature. In conversations about his work in particle physics, Gell-Mann proclaimed a principle of faith that underlies all research in physics, particularly particle physics. People know it as Gell-Mann's totalitarian principle. One way to state the principle is, quote, everything not forbidden is compulsory, end quote. In other words, as long as something can happen, it will happen. Nothing hides from us in the world of physics. That confidence in nature is the final cornerstone of our faith in the research program of physics. The totalitarian principle played a role in the quest to find the smallest elements of matter. To pursue those basic elements, physicists built large particle accelerators that dumped energy into a small volume of space. The energy turned into new particles. Not just some new particles, all elementary particles that can exist in nature come out from the experiment if you put in enough energy. Now, when I was in graduate school, particle accelerators were no bigger than a football field. They made a lot of previously unknown particles of matter, and around that time, Murray Gell-Mann became famous for describing those particles with his so-called eightfold way, which I mentioned earlier. It turned out to be obsolete within a few decades. As physicists built larger and larger machines, they arrived at today's Large Hadron Collider in Switzerland. It is over 16 miles in circumference. Such very high-energy particle accelerators make so much energy, we now see debris coming out showing there are 29 elementary particles organized in something called the Standard Model. The picture here illustrates the Standard Model of elementary particles. Once again, it was Murray Gell-Mann who had the key idea about what nature is telling us. He proposed the idea of quarks, of which we now recognize 6 quarks arranged in 3 generations. 2 of the 6 quarks make up all the matter you and I know. Nice work, Murray. And maybe it is also the end of the road. Physicists aren't seeing anything new. If this barren stretch goes on long enough, physicists have to believe they have reached the end of the road in searching for new elementary particles. After all, physicists believe in the totalitarian principle. So now we leave the standard syllabus of physics and take a look at the world you and I occupy, the living world. Our everyday world has completely defied Murray Gell-Mann's totalitarian principle. The universe is now 13.8 billion years old, while the Earth itself is only 5 billion years old, and yet every moment brings new life, new forms, new patterns, none seen before. Here is an artist's impression of the spiral growth of the living world since the beginning of the Earth. I can't lead you through all the events in this illustration. I'll just call out a couple of illustrative milestones. According to the best science, chemical evidence of life on Earth appears within 500 million years of a nasty early period known as the Late Heavy Bombardment. That waiting time was short. Thus, we think that it must be easy for a random chance to put together autocatalytic chemical networks that can form the chemical basis of life. Moreover, after a very short time, geologists can find evidence of single cells building organic sediment. Therefore, the bacteria arose rather immediately too. So far, there is nothing to upset a standard physicist. Bacterial life is possible, so it just happens in some warm pond somewhere. According to the totalitarian principle, life must arise in every warm pond on every suitable extraterrestrial planets. But then, billions and billions of years go by with no life on Earth save these simple bacteria. Boring, boring billions. Then 2 billion years ago, an event happened that happened only once in the history of life on Earth. A cell arose that is like the cells in your body, like the cells in my body. And like those cells, it is bigger than bacteria. These new cells carry around a lot of DNA, as much as they need and more than they need. We call the cells eukaryotes. Eukaryotes were the new kid on the block 2 billion years ago, and they remain the sole example of their type. All of the cells in your body today can trace their DNA to the first eukaryote 2 billion years ago. This was a singular creation event in the history of life on Earth. It took billions of years to do it once, and in the billions since, it hasn't happened again. It may be that intelligent life in the universe is really quite rare because big jumps in the ascent of life seem to be rare. What I'm driving at is that the history of life, as we know it on Earth, is a history of rare events leading to some successes that are then replicated and filtered by natural selection. It is a history operating within the parameters of physics, but it is a history beyond the syllabus used to teach physics. Eventually, life on Earth included humans, and humans talk to each other. Language is another area where the totalitarian principle from physics doesn't apply to the world of living things as we know it. We now have 8 billion people on Earth. Do we have a proportionate number of languages? No. Although anyone can make up a language, there are far fewer languages. In fact, look at this illustration where we show flags representing languages used in those countries. You'll even find 3 made-up languages, 4 if you count Esperanto. However, artificial languages are rare. What happens naturally is that people learn languages as children, thereby reproducing and propagating the pattern of their mother tongue. People also modify the language as they use it, so when they pass it on to their children, it is a slightly different language. We could call this process descent with modification, as Darwin originally described evolution. And finally, some languages are widely used, while others are not. Gradually, the less common languages are lost. That is natural selection for languages. All current natural languages are related by descent with modification to a smaller set of antecedent languages, just as Darwin proposed for the biological species. Language is another example of something that exists in the physical realm, but language is beyond the standard physics syllabus. Allow me to point out the obvious. Languages have names like English, Russian, Arabic, and so forth. These languages are associated usually with real places on Earth. However, on this illustration, you'll also find languages like Klingon, Valerian, and Na'vi that are associated with places existing only in our imagination. Navi is perhaps the newest imagined language. Humans first heard the Navi speech in 2009 in the movie named Avatar. The language named Navi was created by a man named Paul Frommer at the request of a director named James Cameron. Cameron, Frommer, Navi, Arabic, Russian, English, all names. I could make an endless list of names, and all the names matter because they refer to patterns in the living world, and those patterns play an effective role in what is happening. Consider the name James Cameron. The name identifies a well-known contemporary human who is originally from Canada and who was educated uniquely by college, by mentors, and by experience. He's created highly original works, unlike works produced by others. I first learned about James Cameron as the creative force behind the movie Terminator, so I'm tossing in a picture of Arnold Schwarzenegger playing an artificial intelligence with lethal intent. However, Cameron has produced many other works. Why bring this up? Well, for one thing, Cameron is an extremely improbable agent in our world. Even if you think cooking up the Terminator and Avatar was easy, the same guy directed the development of the most advanced deep-sea submersible vessel shown here diving below the surface. Where is the quality of predictability and determinism from physics in Cameron's life and work? It seems rather that his life is unexpected, unpredictable. My second point is that there is only so much money available to make movies. Because we have the Terminator and Avatar, we don't have a remake of Casablanca, thank heavens. Natural selection is at work everywhere. I'm even part of it when I pick and choose what to watch. So having Cameron's creative output, we don't have something else. Cameron shaped the world by contributions, but also by crowding out other possibilities. I'm taking up a lot of your time. Let's get back to the question. Do you and I have free will? Yes or no? If you've come this far, you can see where my opinion lies. I think the answer is yes, provided you're asking the question in the context of the words that make up the question. That is, we are agents, so the question is about agents like ourselves. It is about freedom, and so we need to consider the boundaries and freedoms of agents. Are those boundaries robust enough that agents act independently, or porous enough that outside influences govern decisions? Looked at that way, the question is a question of degree, a question of coupling versus cohesion, as I characterized the naming of modules before. Maybe not a yes or no answer at all. Of one thing I'm certain, any claim that there is no free will, because the universe is deterministic, is a claim from the last century, and maybe not a claim grounded in current science. I should be pointing out now what is new in science. However, some of you are eager for this talk to end, so I'm going to postpone that part of a discussion to a coda, that is, to a section at the end. To wrap up this talk, I came up with a test. You are welcome to take the test offline. I took the test last January, and I feel I sort of failed the test in a very instructive way. My goal today has been to show you 3 areas of study that you should keep in the front of your mind when you consider the question of whether you and other living creatures can exert free will in this material world. You have the right to expect me to answer the free will question, so you can agree or disagree, but things are working out differently. In the middle of this last winter, I took a 3-week break to lie in the sun with no cares on my mind and no intention to worry about free will. I already had my answer, a firm yes, but as the clouds drifted by, I thought, maybe there is no clear yes or no answer. Why not end this talk with a challenge? Here's my free will challenge. Observe yourself for a few days. Notice how you spend your time when you think about issues that require you to exert will and make a decision. Consider whether you have options and whether you feel you have control. That is, does your decision even matter? I've taken the test, and the answer rather was shocking to me. I had to notice that at least 60% of my decision evaluation time was absorbed in one single issue. Worse, that is an issue where I have no acceptable options. The decision will be binary and both outcomes are bad. I can't change that. I must classify this situation as one in which I have no free will, because I don't like either open option, although at some point I choose. Another 30% of my time seems to be going into listening to cable news and trying to decide what options for the action the president should choose and why the hell doesn't he do something right now. In this case, there are many options that I can consider, and I do. But although I am free to choose, my decision doesn't matter at all. If my decisions are free from constraints, but my decisions can have no effect, is the decision free? I'll just put the question out there. Next 5% of my time was spent making decisions that affect my relationships. In these matters, I have options, and I certainly have control, and indeed I have responsibility for my decisions. For this 5% of my time, I'm thinking about situations where I can exert free will. I can make a positive difference, and nothing prevents me from making that difference. Then a last category involved for me sometimes sitting on the beach thinking about a long-term project that would have great benefits for society, although there is a very low probability it will work out. I'm free to make decisions that have some influence, but the barriers are high, even close to insurmountable. On the other hand, the payoff is inordinately high. So again, I feel a sense of free will in this area of my internal processing. There are two ways to summarize this. I'll say 40% of my decisions are my own, but only 10% really matter. Another way is to turn the percentages into a pie chart and illustrate the categories. The slide locates the percentages on two axes describing whether options are available and whether I can have influence. It is striking how much time I devote to debating decisions that have no prospect of helping myself. Why is this? Obviously, I am much in the thrall of my past injuries and insults, of the chemical balance that controls my mood, and probably other factors a psychologist could elucidate. I'm free to be me, but me in my own chains. That is hard to accept, but it's probably true. So in the end, I could answer yes or no. People in general have free will, but in my case, I see my limitations. On the other hand, we don't need much of a brain to get by. Maybe 1% of our capacity is more than enough. If I waste 90% of my time, where will it ever matter? So what? What counts is what we think and act where it matters. From that perspective, I feel better. Where it matters locally, in my relationships, I try to make the right decisions. I also try to improve the world in general, as improbable as it seems, because that is the only way the world improves, by decisions and actions of people in the world.
That was my take on free will, except for one piece. I left out some thoughts about what there is in physics that you should know. If you are interested in physics, or perhaps you are still attracted to the idea of physical determinism, you may want to tune into the Coda to this talk, which is in a separate file. Thank you very much for listening today.